So for 3-7, we're given a tress that looks like the following. Yeah, my drawing skills are horrible, so. Alright, so we need to find theta, these two thetas. We're given this as 100 centimeters. This side is 80 centimeters, and this side is 80 centimeters. Right? So all three of these triangles are the same triangle. This is 100. That's 100. And all of the sides are equal. So they want us to use the law of sines or the law of cosines to figure out which angle's which. So I can just, let me actually write down the law of sines and law of cosines. Law of cosine is if we have some triangle, I'll say this, where this is alpha, that's too small. So this is gamma, this angle's alpha, call this angle beta, right? Can you, well, you guys probably can't see because they're in the way. It's cool. And then we call this A, this B, and this C. Actually, I'll make this A and that C. Oh, took out a lot. Beta. So that's beta, and I'll call this C. So what's the law of cosines say? Cosine of gamma is equal to what? B squared minus, hold up, I gotta look at the book for this. Squared B squared. Yeah, you could rewrite it as this, yeah, exactly.
Like write in white.
What, the blue isn't good? Alright, I'll do a different color. I'll erase that and redraw it. Redraw in. Is yellow just the better? I don't know what it is. I'm colorblind. Lambda, alpha, beta, A, B, C. So we have the cosine of lambda, B squared plus C squared minus A squared over 2BC. Or we can rewrite this as A squared, which is this side right here, equal to B squared plus C squared minus 2BC cosine of gamma, which is essentially the same thing, just rewriting it. You're just rearranging it. So for this problem, how are we going to find alpha? I would think the first step that we want to do is just redraw this triangle, right? We could just redraw it as one triangle with that as theta, 80, 80, and 100. And we could think of theta as gamma, right? So if we want to compare this to gamma, we go back to the law of cosines, then we would just replace this, and then what would side A be? A would actually be 100 because it's the opposite. It's the opposite side of gamma, right? So A is the opposite side of gamma. It's the angle pointing to the side, right? So right here, A would be 100. So we could write this as 100 squared equal to 80 squared. I got to go back, check out the 80 squared plus 80 squared minus 2 times 80 squared, because it's 2a times, or 2b times c, right? 2bc, but b and c are both 80, so I just made that 80 squared. And then we multiply that to the cosine of theta. Now we can rearrange this so that, actually we should probably have used the other formula instead of this. The solution has it going this way, but the better way of going about it would be using the cosine formula. So we'll start out with the cosine of theta is equal to 80 squared plus 80 squared minus 100 squared over 2 times 80 squared. Because A, remember that A, side A, is the 100 because it's the opposite side of the angle that we're looking at. So we have this as 80 squared plus 80 squared minus 100 squared over 2 times 80 times 80, which we can just rewrite as 80 squared. So then to find theta, all we're going to do is take the inverse cosine of this. So we'll take theta equal to the inverse cosine of this quantity right here. 80 squared plus 80 squared minus 100 squared over 2 times 80 squared. This is equal to 77.36 degrees. 78.75. I wouldn't even say I don't think it's a rounding error. That's too. You might have flipped a sign, or you might have switched up your A and B terms. You might have confused an A and B or an A and C term, and that would throw off your answer because you would be subtracting 80 and adding 100 squared. Instead, we should be adding 80 squared plus 80 squared minus 100 squared. So if you messed up one of those sides, you could have got that answer. And that's all it asks for 3-7. Any questions on that one? Pretty straightforward. Yeah. You could, well, the law of sines asks for angles, and we don't know any angles, right? So the law of sines, let me rewrite it on this page. Law of sines is equal to, what is it, the sine? Let me redraw our triangle again. Where we have gamma, beta, alpha, A, C, B. So we have, it's the angle, so it would be the sine of lambda over A is equal to, let me double check real fast. Okay, so we have, yeah, so it's going to be the sine of gamma, which is this angle right here, over the side perpendicular to the angle, is equal to the sine of beta over what? The side pointing, so it'd be B, equal to the sine of alpha over C. And so in order to use the law of sines, you would need to have at least one angle. And we don't have any angles right now. We could also solve it another way because we have two similar sides. We could split it down the middle, and we have the sides. We can make it two right triangles that way, and then we could just use Pythagorean's theorem to find half of that angle. So let me draw it out. So what you could do, we're looking for this angle, right? We know this, and we know this. One way that, if he doesn't ask you to use law of sines or law of cosines, the way that I probably would have went about it, we'll just split it down the middle, make two right triangles, so we have this side is 50 and that side is 50, and then you can get this side, and then once you have that side, you can find the angles that way. And then you find this angle, which is just half of the overall angle you're trying to find, so then you would just multiply that by 2. That's another way of doing it. But for this problem, I think it specifically asks to apply law of sines or law of cosines. So the next problem that we're going to do is 311. .311 is something similar to what you had to do for lab on Wednesday. This is a one-link planar robot that's drawn like this. So this is a 135-degree angle. This point is P, x of y, and we're given the length as 1.5 centimeters, or meters, 1.5 meters. And we're asked to find x and y, right? So how would we go about doing this?
I use the
45 degree, it is a 45 degree angle. Yeah, we could do that.
So,
But
I took the cosine.
exactly, that's what we want to do. We want to multiply the magnitude for x, because essentially we're finding the x component, or how much x there is along this line. So x is equal to the cosine, because if we drew it as a right triangle, we know that it would be, cosine is going to find our x component, and sine is going to find the height of it. So
And for y, it will be the same. It's like 45, right?
the answer will be the same. The only thing that's different is the direction, or the sign of it, essentially. The sign's going to be negative for x. So what you would do is multiply the to find x component, you would multiply the magnitude or the length of it. Length is probably a better description. So we would go with length times the cosine of our angle. Y would be equal to L times the sine of our angle. And we're given the angle is 135 degrees. So if we plug 135 degrees in, it will account for the negative signs and the positive signs. So we'll do x is equal to 1.5 times the cosine of 135 degrees. This is equal to negative 1.061 meters. And y is equal to 1.5 sine of 135 degrees, and this is equal to 1.061 meters. And this makes sense, right? We know that this is in quadrant 2, so the x component is going to be negative. And we know that it is a 45 degree angle, so that both components will be equal. So this makes sense. Any questions on this problem? Pretty straightforward. hold up.
What can you say about the surface of the parallel from parallel circles? Are they the same or are they different? Well, what did your answer say? Yes. No, no, they're all different.
Okay, for the first one, I guess one.
Well, no, you're talking about two different things right now. Current and voltage are completely different. So current, what can you say about the current in the parallel circuit?
All right, so let's do Let's do 318. To do 318, we really just set up, this is for two-link, right? Two-link robots. We can set up each problem in a similar way. At least finding the x and y component will stay consistent the entire way. So if we want to find x for any two-link robot, we're going to do it as x is equal to L1 cosine of theta 1 plus L2 cosine of theta 1 plus theta 2. Now if we want to find y, y is equal to L1 sine of theta 1 plus L2 sine of theta 1 plus theta 2. Using this formula, we'll be able to find all of the x components, the total x and the total y of any two-linked robot. So, using this, we can then sketch after we have x and y. We know we'll be able to sketch it. So this asks to find the x, find the y, and sketch it, right? That's what the problem asks. I think I'll do C and D, because I think if you guys can do C and D, you should be able to. Yeah, they're both with radians. Actually, is C with radians? No, C is degrees. I'll do radians. I'll do D. No, I lied. C is with radians. So let's do that. So let's start with C. 18C. So we have theta 1 is equal to 3 pi over 4 radians. And theta 2 is equal to pi over 2 radians. And then L1 is equal to L2, which equals 5, right? 5 meters. So one way to see it, if you guys aren't used to radians, you may just want to convert it to degrees. That might be an easy way of just visualizing it. But we know from the unit circle, right, that this is 0 and 2 pi at this point. From here to here is what? From the origin to here, it's 90 degrees, pi over 2 radians. And then this is pi, this is 3 pi over 2, and that's 2 pi. So if it says an angle of 3 pi over 4, that's going to be something that's halfway between pi over 2 and pi. So it's going to be about 135. But if you guys want, if it's not a clean radian measure like that and you want to convert, what you want to do is say, okay, we know 180 degrees is equal to pi, right? And so we could set it up as a ratio. 180 pi is equal to x, some term x, which will be the degrees that we find, of 3 pi over 4. Now, in order to find, we're going to cross multiply. So we have pi x is equal to 180 times 3 pi over 4. Now we're going to divide out pi, those will cancel, these pi's will cancel, and then we'll have x is equal to 180 times 3 over 4. And this is equal to 135 degrees.
Oh, so it's the same as doing 3,004 times 180 over pi?
Over pi, exactly. So that's the conversion. And pi over 2 radians we know is 90 degrees, right? So that's 90 degrees. 3 pi over 4 is 135 degrees. And now we'll draw the first link out. Do you have a question? All right. So we know that the first angle, theta 1, is 135 degrees. Theta 2 is equal to 90 degrees. L1 is equal to L2, which is equal to 5 centimeters. So the first angle, 135 degrees, creates our first link, right? So now this is our new plane. After we have our first link, if we're doing a double link, we create another plane or another Cartesian coordinate. So you're almost rotating it this way, rotating the origin of it that way, so that the new plane is right here. So from here, we're then asked 90 degrees, right? So 90 degrees now from this point, or this new origin. So 90 degrees this way is really 90 degrees that way, which comes back to the origin. Yeah.
So why is that?
The reason why the 90 degrees is because now our new plane is, I guess it's almost a flipped version of it. So it's flipped and it comes down this way. And the reason you know it's going to look like this is because when we plug in our values, you're going to see that our y component equals 0. So if you're confused about which direction, should I go this way or that way, once you solve for your values x and y, you'll be able to see that it should go this way because the total components is equal to y, or the total x components is equal to 0.
So what if it was negative 90?
If
Would it be the other way?
it's going to be the other way. And I'll let me just go through it and go through the math, and you'll be able to see why. So if we're finding x is equal to what? L1 cosine, if we go back, x is going to be equal to L1 cosine theta plus L2 cosine theta plus theta 2, right? So let's plug this in. So this will be 5 times the cosine of theta 1, which is 135 degrees, plus 5 times the cosine of 135 plus 90 degrees. So our x equals negative 7.071. Now if we want to solve for y, we do the same thing, but it's a sine instead of a cosine. This comes out to equal 0. So our y, and this is our total x and y values. So this means we went, for the total 2-link robot, we went over 7 are 7.07, and it's negative, so we went to the left. But if we were looking at y, how much we went up 0. However, if we went with 90 degrees, or if we went with the other way, we would know that wouldn't be the case, right? Because instead of, we would then have something that looks like this, right? So now our total y component, the total length here, is no longer 0. So that can't be the case, right? Because we solved for y equal to 0 right here. So we know that it has to be this drawing right here. Does that make sense?
Yeah.
Okay. You had a... Okay. What, for the negative 90? All right. It's very similar to this. So really, the first step, I guess, you guys should do before you actually draw it is maybe solve it first. Solve the math portion of it first. And then you'll find out your total lengths of x and your total lengths of y. And this will help you decide which direction you want to go after your first plane. Because if you think about it, even if this was the origin, intuitively it would make sense to go this way, right? But when we plug in the numbers, it's actually rotated the other way. And so our 90 degrees is this way. It's upside. Straight up, yeah. Actually, the first time going through it, for me, I actually did it that way. Then once I solved out the math, I knew that wasn't going to be the case. So now let's do D. D tells us what? We have theta 1 is equal to what? 3 pi over 4 radians. Theta 2 is equal to negative pi over 2 radians. And L1 equals L2, which equals 5.
So this will be pointing
Other direction. And the reason why, we'll just solve it. We'll solve the math the first time. First, we just tried sketching it. It kind of didn't make sense. So let's do the math first. We know this formula is going to work for whatever two-link robots. So let's just find the total x. X is equal to L1 times the cosine of theta 1 plus L2 cosine of theta 1 plus theta 2. This is equal to 5 times the cosine of, we know that 3 pi over 4 is equal to what? 135 degrees, right? Plus 5 times 135 plus 90 degrees. Actually, I'm sorry, it's minus the 90 degrees. This answer comes out to be 0. So
like when it's pointing like kind of, it's like the y is 0, but when it's pointing like right, it's like the x is 0.
well, they're first going to start off going the same direction when we draw it, because our first angle is still 135 degrees, right? Theta 1. So the first angle that we're drawing is going to look like this, 130 degrees, right? So it's still that way. But now when we have it as negative 90, we can kind of think of this as it rotating. Oh man, how could we rotated it. So we kind of rotated it this way. So it came around this way. So you can think of this portion going around, and now we remade our coordinate system as this. And then that. It kind of, you guys, it's kind of, all right, you get it? All right. All right, so now let's solve for y. y is L1 times the sine of theta 1 plus L2 sine of theta 1 plus theta 2. So this equals 5 times the sine of 135 plus 5 times the sine of 135 minus the 90 degrees. This equals 7.071. Okay? So before our y component was equal to 0, now the x component is equal to 0, which means that it's not going to, the total direction, there's going to be 0 x component. So when we redraw this now, we know that the first angle is 135 degrees right here out this way. Now in order for this to not have any x component at all, it needs to go 90 degrees, because they are the same length, 90 degrees in this direction. So this is 5, and this no longer creates any value in the x. There's nothing in x or y. It's only contained, that was horrible. It's only contained in the y portion, or the y component of it. Does that make sense? Is there any other ones from...
Okay, so when you have theta 1 equals negative 30, and theta 2 equals negative 25, so how's that?
Well, negative 30, you would first start with... It would be in the fourth quadrant. We'll start off with the fourth quadrant, and then...
But then I don't know how to make where...
Which problem was it? I think it's F, right? Negative 30 and negative 45.
Yeah.
So then, this one, it comes out negative 30, right?
Yeah.
Negative 30, and then we draw it out this way, and then they're saying that negative 45 would then be 45 degrees this way. So negative 45 degrees here.
Okay, yeah, that does make sense.
That makes sense?
Yeah.
All right.
Okay. Cool. Thanks.
No problem. So that's the general idea on solving these two lengths. All right. Any other questions? All right. So I'm going to end the video now, and then you guys are more than welcome to, if you didn't finish up your lab, it's due tomorrow, so you guys can work on that. If not, if you have any other questions, we can talk about it, go over the problems over the board.